Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at problem of the day 3 for the April month 2024, and we again have a medium question. And by the way, like if you have been following the Geeks for Geeks from the days, so you must be knowing that from the last few days we are again and again getting questions which are revolving around the topic of trees. So I hope that you will be trying that, and definitely they are very good questions. And if you have missed that, then definitely it's a reminder for you to go and try that again. That you will definitely appreciate this, and they are really good questions by the way. And coming to today's question, we again have a question revolving around the topic of trees. And to be specific, it is about BST, right? What is a BST? What it all resembles? You can just pause this video once and have a Google search out of that. I'm sure you will get some useful information. And by the way, BST, the first B stands for the binary, right? It's actually the binary search tree. So the only information that we need from the BST is that it will have two children, okay? Each node will have at max two children. That is the only information that we are going to use. Rest all is, as simple as you can consider this as simple as a tree which has each node can have at max two children. That is the only fact that we are going to consider out of the BST. There is no, as such we are using BST in this particular question. Okay, that's the only thing which I would like to mention. And there is one more trick here. Without that, you won't be able to solve this question. That also I will mention. But for now, let us go through the theory of the question. Okay. So it is kth common ancestor in BST, and the question is here: given a BST with n basically refers to the number of nodes. Okay, so here they are mentioning that the number of nodes can be greater than or equal to 2. Okay, that is fine. Find the kth common ancestor of nodes x and y in the given tree. Okay, return -1 if the kth ancestor does not exist. Okay, nodes x and y are always present in the input of a BST, and x is not equal to y. So yeah, things are clear here. Fine, but first of all, let us try to understand what all is given to us. Okay, so these are the things given to us. If a value k is given, what is k? We'll have to find the kth common ancestor. Okay, that is the k, right? What are x and y? X and y are the value of nodes. Okay, nodes x and y are given in the tree. You'll have to find the ancestor for them, and to be specific, the kth ancestor. Okay, so these things you can also understand on your own. But why to watch this video? In this video, I will tell you some of the things which you may not be able to understand in the first two. Okay, so first of all, if you are solving this question in Python, to be specific, okay, so x and y are basically just numbers. Okay, see, this doubt will definitely come to your mind because see, here they have not given any specifically what is x and y. They're simply giving the inputs here. Okay, these things, but to be specific, x and y are going to be integers. They're not going to be instance of this particular data structure node. Okay, so they're not going to be object of node. They're simply going to be integers. So what I mean to say is, for example, they say 50 means you'll have to find the node which has the data is equal to 50. Okay, as simple as that. They're not giving the direct pointer to that node. As simple as that. Okay, so to be specific, I hope you understand what I'm trying to say. You will have to go through the whole tree and you will have to find where is x, where is y. Okay, you are not giving pointers to them. As simple as that. And k, anyway, k can be integer only. There is no possibility that it can be a object of this particular class. That is one thing is very clear. If you have solved this question, I mean, if you have at least started this question, I am damn sure that you will be understanding what I'm saying. These are the doubts which even came to my mind while I was solving this question. Okay, so I've already done all those things here, and to save your time, I'm just saying you that. One more most important part is that, see here, what is the expectation here? They are expecting the time and space complexity to be O of height. Okay, O of height of the tree. And whenever you see these kind of things, the first thing that should come to your mind is which traversal you want to use. Okay, either you can use the DFS or the BFS, and either way you will be able to achieve these particular complexities. Okay, that is the first thing. Another most important part in this question, okay, if you are in an interview, definitely I will expect you to ask that question first. Okay, so the question is, when I say kth ancestor, what exactly I mean to say? For example, let us say, so the idea here is, let us say I'm talking about 50 and 60. Okay, I need to find the first ancestor of 50 and 60. Okay, in this case, can you quickly tell me what is going to be the answer? So the question that should come to mind is whether whether a node can be ancestor of itself. Okay, for example, see, 60, when we say 50 is the ancestor of 60. Okay, I hope the screen is visible to you. 50 is the ancestor of 60. That is fine, perfectly fine. But what about 50 to itself? Whether 50 can be considered as an ancestor of itself? If that, see, that will matter, right? When we say kth ancestor, we'll have to figure it out. What is the first ancestor? Then only we can go for the second ancestor, right? So that is the one of the important part. They have not mentioned anything about it. Okay, to be honest, and if you do not know this particular thing, I'm damn sure you will not be able to solve this in the first two. Okay, so understand that I've already designed a test case here. You can see here I am giving 50 60. Okay, and the kth ancestor is 1. Okay, that time means I want to find the first ancestor for nodes 50 and 60. Okay, what are 50 and 60? They are here. Okay, 50 is here, 60 is here. Okay, this is slightly deviated from the input they have given. I have made it 50 and 60 and k equal to 1. Okay, so can you quickly tell me what will the answer of this? If you have not tried it out, okay, let me try it for you. The answer is going to be 50, by the way. Okay, let me just compile and run, and the answer is going to be 50. If you, yeah, you can also check the same answer is going to 50. Okay, when I say 50 and 60, and if you have to find the first common ancestor, the answer is going to be 50. So that the point very clear is 50 is going to be ancestor of itself. You will have to treat it as the ancestor of itself. This is something which you should get clarified if this question comes in interview, because see, the if you see the definition of the question, they have not mentioned that. Okay, but if you do not see consider this fact, then definitely will get a wrong answer. For example, let's say for 50 and 60, if you say 30 is the first ancestor, then definitely the whole calculation itself is wrong, right? That is the first point. The next thing is that if the case ancestor does not exist, in that case, we have written -1. What that means is, for example, say let us say 50 and 60. The first ancestor is 50. The second ancestor is 30, right? Let us say that in the question we give k equal to 3. That is, we want the third ancestor of 50 and 60. In that case, there is no third ancestor. In that case, we have written -1. So these are some of the edge cases. You can say the edge. I can say the possibilities that can happen here, and I have explained to everything. Okay. Now let us deep dive into the code. The code is going to be very, very simple. I'm going to use a simple DFS. Okay, I'm using just two variables and a simple DFS to achieve the answer. What is the answer? Let us see. So what I'm doing is, first of all, very simple thing. If the root is none, simply return 0. So idea here is, see, I'm using a DFS, right? What is a DFS? I will go for each you can say a branch. I will go to the depth of it, to the possible depth of it, and then I will come back and go to the next possible branch and so on. Okay. For example, if I am a 30, I will go to uh, 21st. Then I will come back to 30. Then I will go to 50. Then 40 and come back to 30. Sorry, 50. From 50, I will again go to 60 and come back to 50, and I will come back to 30, and I will be completing the DFS. That is the basic trajectory I will be following. And let us see the code now. First of all, see, this is the code. Okay, I will explain this first, then we'll go to the rest. Okay, so first, if the root is none, simply return 0. Okay, what else? I am using a DFS of left, I am using a DFS of right. Okay, R is the root. Okay, by the way, R is something passed to the function. It is the root. Okay, next. Now, for every normal case, it will return 0. Okay, for example, if I am 50, it will return 0. But there are some special cases. For example, let's see here. If r dot data is equal to x or r dot data is equal to y, in either of the cases, the value to be returned will be incrementing by 1. Okay, you can see for each case, I am calculating a value to be returned. Initially, it is 0. If my r dot data is equal to either x or y, in that case, value to be returned is incremented by 1. Okay, then what I'm doing, see, also, whatever is the return value for r dot left and r dot right. See, whenever I'm calling the DFS for the r dot left and r dot right, that is, whenever I'm traversing the left and right subtree, I'm also, whatever is the return value being returned, I'm adding it to my value to be returned. Okay, normally, the normal case it will be 0, but in case if in the left subtree, let us say x is there, and in the right subtree y is there, in that case the value return will be 1 in either case. Okay, as you can see that. So that's what I'm doing. If I will explain on this, but for now, just bear with me. If the current node which I'm having is having a data which is equal to x or y, in that case, value to be returned will be incremented by 1. Okay. In all other cases, we'll be returning 1. Okay. We'll see that how. And then ultimately we are comparing. See, any ancestor of, see, for which, let us say x and y are there, right? So any ancestor of x and y will always have a value to be returned equal to 2. Okay, that is definitely true. Okay, then what we are doing is, we are seeing, well, ancestor visited, we are incrementing it by 1. Okay, I will initialize the ancestor visited to be 0. Every time the value returned is equal to 2, that means I am visiting ancestor, so I'm incrementing the ancestor visited equal to by 1. Okay, and then I'm checking if the ancestor visited, that is the number of times the ancestor visited, is equal to k. Okay, that means we are at the kth ancestor, and that becomes my answer. Okay, I'm not returning it as of now, I'm just saving it. Okay, in instance it will be -1, and I'm just saving it with the data, and finally I'm returning that as the answer. Okay, so let us now trace it how it works. Okay, let us say for the same case, let us say we are at 50 and 60. Okay, we are at 50 and 60. So let us say this, I have come to the part where I am at 50. Okay, r equal to 50, this particular value. Okay, r equal to the node which has the data equal to 50. Okay, we are at 50. Then what will happen? I will do a DFS of r dot left. Okay, we'll go to 40 and we'll come back, because 40 is not my x. Okay, in this case my x is 50 and y is 60. Okay, I hope you understand. Okay, in that case, value to be returned is 0. Okay, please make it very clear. And then we'll do a DFS of r dot right. In this case, the right subtree has 60. Okay, which is going to be one of my x and y, right? X comma y. In that case, this particular value will be 1. Okay, initially it will be 1. Why it will be 1? Because see, when we go to 60, this particular part will make the value to be written as 1, and it will return that value. Okay, it will return that value. So when I receive that value when I am at 50, right? When this particular function is at 50, you can think of it as a stack. Okay, every function call resembles a stack. Okay, so when I'm at 50 and the value of this is written, okay, values of r dot right is written. Okay, in that case it will become 1. It will be 0, and then it will become 1, because of 60 is the because 60 is present in the right subtree, right? That is that. Now finally, because 50, we are at 50, right? 50 is also a value among x comma y. Okay, so this particular value will also add a value to it. Okay, it will add 1 to it. So the value to be written will become true now for the first time. Okay, then I will check if the value to be written is 2. This is true, right? This is true. So what I'm doing, ancestor visited will be added by 1. Okay, I'm adding it by 1. So in this case, if you are saying my input, okay, what I'm doing, I am giving k is equal to 1. That is, I'm on the first ancestor itself. Okay, so in this case, the ancestor visited will be equal to 1. Okay, and we are making answer is equal to r dot data, which is 50. Okay, that's what actually is written also. Okay, as I showed you, for 50 comma 60 and k equal to 1, the answer written itself is 50. Okay, whatever is the answer, you have to return it, and the the driver code will be printing it. Okay, I hope you can go through the driver code as well. These are good approach to see the driver code first, and then you can see they are simply printing it, right? Whenever you see such a thing, you can safely return it. Okay, otherwise you will have to figure out what to be done. Okay, whether you have to print it yourself or what. So this you have to do. Okay, so the only important part which I feel that you will not be knowing without seeing my video is that a node in this particular question is treated as an ancestor of itself. If you know this part, then definitely you can solve this question. That's what it is. Okay, now if I submit my code, I've already submitted, by the way. Let me show you that. You can see it is getting accepted. Okay, I've already solved it in Python and in Java as well, but this particular code is Python code. So yeah, fine, that was all for today. If you want, okay, I can just do a run for the sample code at least. I've already done that, but if you want, okay, let us do it again. So the answer will again come as 50 because I've given the 50 and 60 as x and y, and for k I've given the value of 1. It is taking time, but I've already done it for you, so the answer will come still the same. So I hope you've understood what is in this particular question. The answer is very, very simple. See, yeah, you can see the answer is coming as expected. Okay, so see, the idea is very simple. Whenever you find x and whenever you find a y, okay, return the value of 1. Okay, return the value of 1. That means whenever you are ancestor of x and y, the value that you got from the the defense call of your right and left subtree will be, if you add them, you will definitely get a value of 2. That is the basic idea behind which we are making the solution. So whenever you have that 2 value, that idea is very simple. For example, at 50 and 60 means any ancestor of 50 and 60 will have a value of 2 written. Okay, value of 2. The next part of the question is we have to find the kth ancestor. So that's why we need another variable which I'm making this. Okay, ancestor visited. So for each time I visit a node which has a return value of 2, I will be incrementing this by 1. Okay, as you can see here. And whenever we reach the value of k, that particular node's data, I will be saving it in my answer variable. Answer is initialized 1 minus 1. Okay, it is basically minus 1 because we have to return minus 1 if the kth ancestor does not exist. And finally we return the answer. Okay, this is the part. So I hope I understood this. And but just one point I want to mention is that if you are new to Geeks for Geeks, please go and back and solve the last 3-4 days problem of the day questions, because they also are from trees and they're very, very good questions. See, trees is the only topic where it's very, very easy to understand and imagine steps. Okay, in graph it becomes complicated because there are so many edge cases coming. Okay, there can be isolated nodes and there can be so many things. There can be circles, there can be links and all those things, right? So, but in case of trees, things are very, very simple, and especially in this question, they have mentioned it as a BST. So, see, whenever you're in interview, you will have to, explain each of this and why. See, first of all, the interviewer will ask you is, in this particular question, we are having a BST. How you are making use of it? So, if this question comes to you, the answer which I think of it will be, see, they have mentioned BST, but the only thing which we are using in this case is that binary word. Okay, the word B. What is the word B? They are just saying it's a binary search. That means each node will have at most 2 children, and that is the fact which I am using. Okay, so we are only calling the difference from the left and right subtrees because there can be only 2 children possible. There cannot be more than 2 children. Okay, that's what we are trying to use it here. Okay, this is the only thing which I am using in this particular question. Other part, uh, as such, I am not using it because see, binary search tree basically means that any value in the right subtree will always be greater than the node. Okay, for example, here 30 is there, so any value in the right subtree will always be greater than 30, and that is true also in this case. I'm not using that particular fact. Maybe you can also think of a solution where you can use that fact, but I do not see that happening because even if you find a value like that, still you will be coding this much for sure. Maybe that will be addition to this particular code. Okay, so I do not see any need to use that particular property, so I'm not using it. So yeah, friend, that was all for today. If you like my solution, please do consider subscribing to my channel. From last few days, I was not able to upload the videos due to work pressure, but yeah, definitely we can start again. There is always a possibility to start again, right? So yeah, friend, we'll see you tomorrow. If you like my efforts, please do consider subscribing to my channel. Yeah, we'll see you tomorrow. Thanks a lot.